And welcome back. Yes, this week we're going to be talking about the STM32 again, but in a slightly different way. I've been programming it using this FTDI interface between the USB and the serial and all these wires, and it's been driving me absolutely nuts, especially when you plug in these wires into the wrong holes for about 10 minutes and wonder why you can't program the thing. I want to move from this to something nice and neat like this one at the back. Look how great that is. I'll show you how we get to there. And for those who have eagle eyes, right at the back there, we have a black pill. What's so different about that? And why was I told that that worked with a USB? Spoiler alert, I couldn't get it to work. And not only that, we're going to have a revised speed test, given all the flack, the constructive comments I've had about that speed test after the people who make this video possible. Be right back. I'd like to give a big shout out to PCBWay.com. PCB prototype the easy way. Ordering from their website is easy. Enter your dimensions of the PCB into the little box, choose how many PCBs you want, and then press the quote now. You can then modify all the parameters to the way you want your PCB to be made. There are quite a few options. And there are quite a few shipping options too. Choose the one best suited for you. Look at the range of boards they can produce here, and I know from personal experience their boards are really second to none. New users get $5 off their first order. So why not try them out now? And we'll be talking about the PCBWay PCB that I made, that one you can see at the back there, in just a minute. But first let's talk about this STM32 a little bit more then. As you know from the previous video, that one that's showing at the top there now, if you haven't watched it, could be worthwhile. I had difficulty getting the USB port to work. I say difficulty, I mean it was a total disaster. No matter what I did, if I plugged a USB plug into here on my computer, it always said USB device unrecognized, and it had a big red cross against it. And I installed drivers and I uninstalled drivers, I installed this, it drove me mad. Everything I could do didn't work. And it wasn't just my PC, I thought it might be. I've got a little laptop that's quite nice, and I thought I'd try it on that. Exactly the same. So I'm thinking, why? How do you guys get it to work? I've no idea, but I can't. I thought, all right, let's just stop trying to get it to work. We know that the FTDI interface, this one here, that you plug a USB in one side, 4 wires, well, 2 of which are power, as you can see, to power up whatever it is you're powering up, and then just effectively the data plus and minus, in and out, I suppose. So I used this for a bit while I was playing about with, of all things, the speed test, just trying to, experiment a little bit. And of course, then I ended up plugging it into the wrong holes in the board here, because the wires come out eventually, don't they? They're not exactly very secure. And I thought, this cannot go on. I know. A moment of absolute genius. I thought, let's go and use those wonderful people over in PCBWay and create a PCB. So I did. It's this one here, but you can't see the PCB because there's so much stuff on it. So I've got another one here for you. Now this PCB, as you can see, it's just very, very simple. You put the blue pill in here, in this area here with the USB at this top. You put the FTD in here with the USB at the top as well. Now there's a couple of other little bits. I thought, okay, I can do that bit. So I can connect the wires that I need to. Only 2 wires. The TXD here goes all the way around over to here, and the RX, this one here, goes all the way around the back somewhere. Have I got it on the other side? I can't even remember. There it is. It goes around the back to one of the pins up here. I think it might be A9, or there it is, A9, A10, something like that. Anyway, so having done that, I thought, well, that's sort of almost a waste of a PCB, isn't it? I mean, now I've got this thing done, what else can I do? So I thought, well, one of the things I don't like about this is the constant swapping of this little jumper. Let me get one a little bit closer, get this blue pill here. Now, as you know, I've already changed this jumper to one of these ones with a handle, so you can get the thing on and off pretty easy. But and that works well. I mean, I've got no issues with that as a standalone solution. But I thought, well, why would I want to do that if I've now got a PCB that I can customize? And I thought, well, what I can do is put some little headers here, connect these to my boot, and then have a little switch here that will turn it into run and program. I mean, that is, I thought, why not? Why not? You've got to do these things, haven't you? And then I thought, well, if I'm going to do that, how do I know that I've put it in the right one? I know I can have some SMD, resistors and LEDs down here to tell me that I'm in the right mode. I thought, goodness me, SMD, me. I mean, you know, it's amazing. And then I thought, okay, one other thing, we need a reset, because when you change the mode from here, from programming to run, you need to press the reset. So I thought, well, I'll put a nice big reset button down the bottom, and that's exactly what you can see on this one. So if we just look at this in a little bit more detail, I'll turn it around in the same orientation. So here's the blue pill, just plugged straight in, nothing else. Oh yes, I put that little jumper just tucked on the end there so I don't lose it. So these three wires, just get hooked across like that, and I've put some hot glue on this so they don't come apart, so it's easy just to plug in here. Well, it is when you're not trying to do it on camera, believe me. We'll just leave those loose. The FTDI plugs into the base here, switch, couple of resistors, LEDs, and a big fat red reset button. Brilliant. So you can hardly go wrong with that. I'll give you a demo in just a second. You'll see how it works. Was there something I could have done differently or wrong? Well, yes, there was. As simple as this board was, one thing I did wrong was not adhere to the footprint outline of this reset switch and the LED, which is only partially visible through there. Look, it overlaps. If I can get close enough, you'd probably work it out. You're only talking about 2 millimeters, but I didn't take enough note of the footprint. Why? Because I didn't create a schematic first. I just went straight into the PCB, thinking I'm just connecting 2 wires from here to here. Well, 4 including the power. Why do I need to draw up a schematic, a circuit diagram? Well, the reason being, of course, it grew from there, didn't it? And if I'd done a proper schematic with all these connections, it would have pointed out the fact that this footprint was overlapping that, and it would have been a little bit better. Now, the other thing, if you notice, although the FTDI plugs in rather nicely to the sockets there, I can just sort of wiggle it loose and you'll see, okay, so that plugs in. But when it is plugged in, it's at the same height now as the blue pill. Now that can make it slightly awkward to get in pins and things or DuPont cables in on here. So what I'm thinking is this. Let me just show you. So this is what I would consider doing. Instead of having sockets on that board, just plug that in directly, solder it up, trim the pins down so that this is now a permanent part of that board. Hang on, I've got to take my glasses off. I can't see my screen now. Yeah, tell me about it. So that would make the height differential far less. And I'm thinking about doing that with another board. Well, this one here, I've got in my hands, in fact, just to see if it works out easier. I could try and get that LED that's down here moved up a little bit, but I'll probably live with it. As you'll see, it's not a disaster. And that's about it, really. Frankly, it works pretty well, I think, apart from that. So let's plug this in and see what it does and how easy or not you think it is to use. Right, well, let's load up any old sketch onto this just to prove it all works and how you use that little board. Just before I do it, I thought I'd just show you the settings for this particular thing. If you've not used an STM32 before, it's simplicity itself. You have to add in the boards using the board manager, which I've covered in some detail in past videos. Yeah, that video there shown now, that's the one to watch if you want to know all about this board. But basically it's a generic STM32F103, that's the key bit, the F103. All this bit I think comes up as default more or less. And this is interesting, although it's come up or has asked me how much flash do I have on there, 64 is the official amount, but in all seriousness, most of them do come up with 128. And what everybody is saying stop saying that, because otherwise ST Microelectronics is going to say, right, we're going to charge more for these because they got double the memory as what we're saying. But anyway, it's 64 officially. Now it says here upload method STM32 bootloader. That's not right. I'm going to be using serial because that's what we've got, isn't it? A USB to serial converter. So I'm going to change that. And CPU speed, well, the standard is 72, so that's what we'll leave it as. Optimize. Well, smallest, which is the default. Now, what does that mean? Now, I got this totally wrong, and I was discussing this with my engineer friend, who thought it highly amusing that I'd thought it was the wrong way round. Well, I thought what it was saying on here is how quick do you want this thing to compile and finish originally, because it's not. What it's saying is how fast do you want the finished code to be, or do you want the code to be as compact as you want? Now, let's think about this for a minute. If you've got limited space, you want the code to be as compact as possible, which means you'll have a core, for example, and then maybe various subroutines around the outside that you're calling and running and all the rest of it. And for all I know, the GCC compiler might even put some things into little subroutines. I don't know how clever it is, but certainly your little functions that you've written will be called as necessary. However, if you ramp it all the way up, say, to fastest, which means you might get a huge program. But what it's saying is, well, to be fastest, all these little subroutines you've written, every time you make a call, I'm just going to copy that entire code into your main program so I don't have to make that jump. And you think, well, how does that help? Well, because the code, when it's running serially in assembler, of course, it's making a jump from where it is, run your little subroutine, which is elsewhere, and do whatever it needs to do and memory and all that, and then come back and reset all the pointer information, stack information, program counter and everything else so it can continue. And that is an overhead in the sense that it will probably take a few nanoseconds. I jest, I don't know how long it will take, but certainly, you know, a measurable amount of time. Well, it says I'm not going to do all that. I'm just going to copy this code that you've said is a subroutine, and I'm just going to copy that in line. And oh, look, you've called it again here. Well, I'm just going to copy it in line again, and there, and there. So you might have 20, 30, 50 times this little function that you've written in line now, which you would never do writing it in native source code. It would be ridiculous. We all adhere to the dry principle. That's the don't repeat yourself dry principle. You write it once and then call as many times as you need. But if you compile this with the fastest setting, it's going to drag all that back in, and you don't care about that, because what it means is it then runs everything without having to make these hops off to various subroutines with all the stack pointers and everything else. Okay, so that's what that means, which is blindingly obvious now, isn't it? But there we are. I got a little bit confused with that. Oh, and then of course there's debug. That's why in fact got confused. It says smallest, fastest, and then debug. Well, debug of course is the absolute slowest possible compile method, because it's going to add in lots of stuff into your code so that it can debug. Now I don't know anything about the compiler we're using here, the AVR GCC compiler, but when I was working, say, with Visual Studio and C# using the .NET compiler, when you had debugging, it made the final code 10 times as big, so that it could literally run each statement one by one. And I'm hoping that ST-Link, that little device, this thing here, one of these, is going to let me do that in the future, but I haven't got that far at the moment. So of course the debug will put lots and lots of stuff in there so that it can run a line of code and then come back and stop until you press a key and then carry on again, and hopefully allow you to interrogate some variables as well. Okay, that was the long answer to the optimize thing. The port it comes up on, and that's the end of it really. Okay, right, I think we need to upload this, and I'll show you what happens on the board. Right, so I've shuffled over a bit here, so you can see behind my head at the board and the IDE at the same time. So all I'm going to do is press compile and it will try and upload it. So what would we do normally on the STM? Well, we'd move the jumper across from one position from boot 0 to boot 1, press reset, that awkward button around the back there, and it would do it, and then we'd have to move it all back again to run it. Sometimes it runs it straight away without having to do anything. But it's a bit hit and miss really, and depends on the board you've got, I think. So all we do on this one, as you can see, it's all powered up and fired up, and it's currently green LED. Yes, I know that LED is somewhat bright. In my original spec I said put a 1K resistor in series with that because it's running on 5 volts. But I thought I had some 470s. I thought, well, 470 will be alright, nice and bright. Yeah, it's dazzling me and the video camera at the same time. Anyway, so that's run mode. You can see it says run down there. Well, I'm going to move that to program. I think there's something dodgy with this USB lead as well. It keeps dinging. Anyway, so I'm going to move it to program, which means just sliding it over. Now the red LED's in there and it's visible, but it's sort of partly obscured by the reset button. But it's all right, you know, it's not a disaster. Oh dear, that USB cable is definitely dodgy. Now you can still see just about the LED blinking on and off here. It's a little bit difficult to see, but I think if I shield it there, look, it's still running the program, even though we've effectively moved that jump across by flicking the switch. So now we have to hit reset, that big one there. They are. Now it's ready to accept a program. So let's upload and see what happens. Don't worry, I'll speed this bit up again. Right, here it goes then. So it's erasing the memory first, and yeah, it's done it. It's uploaded it, and it's all over in a bit of a flash, really, wasn't it? No pun intended. Right, so as you can see, hopefully, the LED is now blinking a double blink, right? So you've got one short flash and one long flash. So we know it's a different program that's running, but it's running without me having to do anything. So some boards are like that. This is in fact not, I don't think this is an STM32. This might be a CKS32, that odd chip. Unless of course it's my modified one with a GD34. Whatever, it's running without it. But if I press reset again now, of course, it will go back into programming mode, which we don't necessarily want. So actually we're going to set it to run, hit the reset, and that's now flashing again. I have to shield it. There we are. And you can see it's blinking away. So from my point of view, the ease of being able to just flick that switch so the red LED comes on, hit the reset, do the upload, and then flick it back to so the green one's on, it's so much better than having all these wires that keep coming out and breaking and plugging into the wrong things. So what else can I tell you about this? Well, there's a couple of things actually. Let's take them one by one. Right, first things first then, somebody put a comment on my channel to say we think the black pill is the one with the corrected USB circuitry, although the STM32 blue pill, the only incorrect circuitry is that it's got a 10k resistor attached to the D plus and ground when it should have a 1.5, but as I said, it made absolutely no difference to me one way or the other. So anyway, I procured a black pill. Here it is, looks very similar. Plugged it into my USB port, and guess what? Yes, it said USB device not recognized. So on your bike, chummy. So I thought, corrected USB circuitry, my aunt. It obviously isn't going to work any better than the standard blue pill. But well, never mind. I can just put it onto this board now and program it. Wrong. This board for the STM blue pill is a different size to this. They've made the black pill wider and with not so many pins. So this does not fit in there anymore. You can just see it's far too wide, and the number of pins is all wrong as well. And the pin layout is all wrong as well. So I think this is useful mentioning actually, that if you were thinking of getting a black pill or have a black pill, don't think it's a straight swap out for a blue one. Apart from the size element, the pins are all different. I say all different. There are many of them different, and so it's not compatible one way or the other. In fact, I don't know why they've made so many different versions. They've apparently got a red pill, which I can't find anywhere. This black pill, which is a newer version of that blue pill, which is all very well, but they didn't make it backward compatible. And because the USB thing certainly isn't fixed to me, I just wonder what this black pill has got that the blue pill hasn't. It wasn't expensive. I actually bought this one locally for about a $5. You can get them for about $2 or $3 from the Chinese websites. But I don't know what the advantage is. Perhaps a couple of you would be kind enough to let me know why the black pill is better than the blue pill. They both run at 72 megahertz. So it's nothing to do with that. Okay, right, what else? Yes. Now, the USB to serial converter that I have, the FTDI running here, and I have several of those, but I also have a CP2102, and I also have a CH340G device as well, somewhere amongst all my stuff. I had a quick look before I did this video, but I can't find them for love nor money. Then again, I can't find my glasses from last week either. They've gone walkabout, so I'm going to get some more of those as well. So yeah, okay, it's me losing stuff basically, but this FTDI is one of the few chips that actually has the capability of being mounted on holes. Let me show you what I mean. Right, so this is Banggood's website. You know I like Banggood because their products are pretty inexpensive and they deliver quickly, so that's why I tend to use them a lot. Now this is the actual one that I've got on my board. It's an FTDI FT232RL, although quite frankly it doesn't matter what sort it is. But this one of course has the holes down here to mount it on my particular board. Should you take one of those. Oh, have I given the game away? Watch right at the end of the video for more news on that. Now if you buy, so that's $149, yeah, you can see that price there. That's if you buy it from China. Now you can of course buy it locally. If you bought it from the UK it costs quite a bit more, $557. See, I wouldn't buy it for $557. Or if you're in the USA, also $557. No, I'd buy it from China and take it at a good price. I mean, it takes something between 4 and 20 days to get to you, so yeah. Anyway, but there are others available. Look, the CP2102, well, that's a UK price. I wouldn't buy it for that, but from China it's $237, which is more. Now it has got some holes, look at the top there. Doesn't quite fit in as well, but I guess if you're going to solder this in flush with the board, it doesn't matter too much. You would have to redesign the board a bit. And of course there's one here which is a CH340G, of which I have one somewhere. I don't know where it's got to. Not quite as good though, because that's got a full-size USB socket this end, when we don't really want that. We want a micro, and there are no mounting holes apart from these things at the back. So all in all, as I say, there are available all these variations on USB to serial converters, but the one that my board is designed for is this one here, and at $149, because look, there's a promotion on until the end of July 31st 2019. I'd get in there and get 2 or 3, quite frankly. So if you do have a serial to USB converter that does have the through holes, yeah, you could change this board design to your favorite device. But frankly, I think the FTDI is a proven design. It's cheap, and well, it works just absolutely fine. I'm sure there's a lot more we could do with this converter if only I knew how to do it. Now, you may have heard in the past there were problems with FTDI boards in general, especially if this FTDI chip was actually on your Arduino, which they were originally. Unfortunately, FTDI got the hump when they discovered that there were some clone chips flying around. Well, not some, there were hundreds of thousands, if not millions, of clone chips being used, but with the FTDI markings on them, allegedly. Okay. And so what FTDI did was release a new driver that could identify whether it was a proper FTDI or not, and immediately bricked the non-FTDI ones. Yeah, allegedly. So I've heard, anecdotally. Okay, yeah, I don't want any kind of lawsuit. And that upset quite a few people. Obviously, when you buy an Arduino or any other board, as a consumer, you have absolutely no idea what's on it half the time, and you buy it in good faith. And lo and behold, it gets bricked at the next chip update. So that was a bit unfortunate, and the FTDI did in fact reverse that decision, and I think they could all work again now, although whether it's, if you've got a bricked one, it might not unbrick itself. So yeah, don't know what you do in that case. But anyway, the new ones, well, one, it sort of achieved their goal though, really, because these FTDI chips apparently are correct ones. There's a little device or a little program you can use now that will tell you whether it's the correct one. Or of course, just don't ever update the chip firmware. All right, just leave it as is, unless you're using this for some other reason, as I've just mentioned, that I don't know, and I don't know what else we can use it for. But don't update the firmware in that, no matter how often you're prompted, unless you're 100% convinced that you have a kosher version. Oh, I've said that word again. The genuine version. Kosher is just a UK expression meaning, well, genuine, the real thing, nothing else. So it's 2 things to be aware of then. FTDI plugs into a board, but a lot of the others don't, and the black pill will not plug into there. So beware about which one you're buying, or take this design of mine, if you like black pills rather than blue pills, and change it for the black pill. I mean, it's this board, I think, really was a little bit, it was easy to do, it was just a little bit tedious with all those connections and naming of all those individual nets, because I hadn't done a schematic first. So do the schematic first, and then all those nets will be automatically named. By nets, in case you're not aware, every single one of these little tracks in here is obviously joined to a different pin, so they all have to be named differently. Although, for example, ground, because it's common there and over here somewhere, that's just one net. In other words, it all joins onto the same thing. And because I put a copper core on the back, that is the ground plane. Look at me talking about ground planes and copper cores. 6 months ago, I didn't know one end of a PC from the other. It just shows how much you can do if you actually go and have a try and prepare to have not quite so good results initially, but as time goes by, I think everybody can receive a good board that they're happy with. Certainly, what would I have done in the past then if I hadn't known about PCBWay or any PCB manufacturer? Well, I would have constructed this on strip board, otherwise known as Veriboard. For example, some of you may remember when I did the AT-Tiny fuse resetter originally, the original video, this is not the new one with the PCB in it, I created a Veriboard or strip board, and it looked like this, because that was the only way I knew I could do it, because I obviously didn't want all this on the breadboard permanently, and it worked. Although you can see there's lots of jumper wires and everything on there, but it worked. It was okay, a little bit big, but it plugged into an Arduino. And then of course I created my board for it, which some of you people have a version of. This is the AT-Tiny fuse resetter PCB, and that works extremely well. Well, it does for me. Some of you have had difficulties, but yeah, it worked really well. So it just shows what you can do once you get into the PCB mindset. And yes, I realise that the shipping costs from China is the big deal compared to the board price, but well, at the end of the day, you have to make that decision on your own. What's more important? Right, let's have another think then. Now, a lot of you have asked me to put up my PCB designs on my GitHub, so I'm going to do that from now on without being prompted. So this is the PCB layout using KiCAD, a great program, once you get into it, that is, and that's what it looks like. Now it looks a little bit colourful, let's say, because I've got all the traces showing, but if I hide some of them, you'll see a little bit more of how it looks. So there you can see all the front copper traces. So these are the traces on the top of the board. Okay, and there's only a few of them, but I chose to do all this kind of stuff on the top because I knew that underneath I wanted the copper core ground plane, so I did that. And on the back, that's all you have. So it's just a couple of wires, not a lot. A few down here just for the LEDs, which was a sort of a late addition really to the design. But I thought, well, why not? Then you've got all the front silk screenings. All this light blue cyan writing is what gets printed on the board. And I decided that, yes, I would write down every single one of these pins because, well, chances are you're going to need them when you're plugging stuff in. And ditto, even though the FTDI, quite seriously, I just wondered why I was writing all these down. I thought, well, why not? If you're going to do it, just spend 10 minutes getting it right so that everything's documented to the nth degree. Now on the back, the writing, now it's obviously all backwards and it's mainly all about what the board does. So let's flip that board so you can have a look. Right, there we are. So this is the board sort of flipped over now on the reverse, and that's all there is to it. There's not a lot on the back apart from the copper core and those few lines. Yeah, that's pretty easy. Now the good thing about KiCAD, of course, is that you've got a 3D viewer, so let's see how well the 3D view matches the real thing. So this is the 3D view, which you just go to View 3D. You can optionally state whether you want the actual components shown, and in green, this green outline you see here is the sort of limit of where those component edges, the footprint effectively of those. You can say, yes, I do want those shown, or I don't. Well, I've got them switched on there. Now the good thing about the 3D viewer, of course, is that by holding my mouse down and moving it, you get a proper well, 100% 3D view. Look at that, isn't that great? That is one of the absolute top 5 useful things about KiCAD compared to other programs potentially. And it actually updates in real time. So if you've got your 3D viewer showing there and you add a bit of silk screen on the front or change a component or something, it will update it normally in real time. And if it doesn't, you just press that button at the top there and refresh it, and it does it pretty much instantly. That's probably one of the best 3D viewers for PCBs that I've seen. So yeah, and around the back as well, there we are, look, see the green outline shows you how big the actual component footprint is. So let's see how well this compares to the real one. Right, well there's the finished product compared to the 3D. Let me just unplug a few bits and we'll just see if we see it a little bit closely. Right, there we are, you get a better view of it now, and I think that's, well, it's almost identical, isn't it? Okay, this big cap on here is obviously not shown on there because I don't think I actually put it down as a switch on the PCB. So what you're seeing there on the PCB in this area, I just put down as 2 3-way sockets, I think, because it's the right size, because I had the switches and I just measured them and put them on. But apart from that, I mean, it's identical, isn't it? Well, you would hope it would be, otherwise nothing would fit. Now you may be wondering why on the real board I've got a slightly different colour on some of the pins. So down this side you've noticed I've chosen red header pins with one single blue one in the middle. That's because on this side of the board all these pins are 5-volt tolerant on the STM32, apart from, for whatever reason, B5. So I thought I'm bound to forget that, so I put a different colour pin in. On this side they're not 5-volt tolerant, well, apart from a couple actually, I've got to be honest. I can't remember where they are now, it might be B11, B10, but I thought, you know what, I'm not going to put in 2 red ones in there. I'll just keep those as not 5-volt tolerant, whereas these ones are. Well, obviously ground isn't, and 3V3 isn't 5-volt tolerant, but you get the idea. It just makes me think a little bit when I use this board now, plugging it up, you know, to breadboards or something. Yes, got to remember to either voltage shift down here or use one of the pins over there. So that was the thing I did for that. Yeah, I think that's probably about it really. What else can I say? Well, about the board generally, the bare board, it's excellent quality. Can't say anything wrong with it. It's exactly as KiCAD has shown us on that 3D. So yeah, not a problem. I've even got designed using KiCAD on the back. Oh yes, at one point, these logos on here from the sponsors of this board, they're the things I put on so that we can identify the board and where it comes from and everything else. Okay, they don't put that on there, so don't get the idea that if you want these boards, you're going to have PCBWay.com stamped all over it, or any of this on the back. That's just me doing it, just to tart it up and to identify the board a little bit. Okay, right, that's it then. So remember, if you know more about the black pill than I do, about why it's why they made it, why make a black pill that is a different size to the blue pill, do tell me why they've done that and what the advantages are. But in the meantime, because I've got quite a few of these STM blue pills now, STM32 blue pills, I'll be using these in this board and be very happy doing it. And maybe one day I'll actually get that USB port running. You never know. But even if we do, we can still use this board, just connect it straight in. Easy peasy. Okay, if you've got any comments, please do put them down below. I love reading them and I'll respond to them, unless they're rude ones. There's only been a couple, it's all right. And don't forget to have a look at PCBWay.com. Thanks to them for letting me design this board and provide it to me. And thanks for watching. See you in the next video. I hope you're finding these videos useful and interesting. There are plenty more videos to choose and a couple are shown below. And if you'd like to subscribe to this channel, just click on my picture below and enjoy the rest of the videos. Thanks for watching.